Most atoms don't ride solo. Instead, they bond with other atoms. Now, bonds can form between atoms of the same element or atoms of different elements. Table salt, sodium chloride.
The symbol Na is sodium and Cl is chlorine. When they bond, they become sodium chloride.
Table salt, sodium chloride, is held together by ionic bonds. Every atom of sodium gives up one electron to every atom of chlorine. Ions are formed, and those ions arrange themselves in a 3D grid called a lattice, in which every sodium ion is bonded to 6 chloride ions, and every chloride ion is bonded to 6 sodium ions. The chlorine atoms never give the sodium atoms their electrons back. If one atom is really strong, it can pull one or more electrons off another atom.
This strength is called electronegativity.
Electronegativity is the ability of an atom of an element to attract electrons when the atom is in a compound.
Here we see Na with an electronegativity of 0.9. On the other side of the table is Cl with an electronegativity of 3.0. Cl is much stronger at pulling electrons. Watch that again. The Cl has a stronger pull on the electrons, higher electronegativity, so it pulled the valence electron from Na.
I really can't express how wonderful and useful the periodic table is, especially this pretty one that lists the electronegativities of most of the elements. The higher number means that they have a higher affinity for electrons, and the electrons will spend more time near that element. You don't have to memorize all of these if you notice that there's a general trend of increasing electronegativity toward fluorine. But maybe you notice that the noble gases don't have electronegativity values. That's because only a few of them will even react with other elements, so their electronegativities are unknown.
We can imagine atoms pulling electrons like this game of tug-of-war. The higher the electronegativity of an atom, the stronger it can pull the electrons. Imagine these two chlorine playing tug-of-war over those electrons in the middle, represented by the small letter E. Two chlorine with the same electronegativity pull the electrons equally and they stay in the middle. In this picture, hydrogen on the left has a lower electronegativity than the chlorine on the right, so the electrons are closer to the chlorine. It's pulling them harder because of its higher electronegativity. So remember, the higher the electronegativity, the stronger an atom can pull electrons. Now we'll answer some questions to practice.